For this given matrix here, we are tasked to use the Gauss-Jordan elimination in order for us to arrive to a reduced row echelon form of the said matrix. If this is a direct version of a linear system, the Gauss-Jordan elimination again will help us solve a or reach the reduced row echelon form, and it will help us define or describe the values of the unknown variables, since we are going to construct a reduced row echelon form. So for this, we are going to apply a series of row operations that will allow us to again reach the reduced row echelon form. I would like to start with this a possibility of interchanging the rows in this given augmented matrix. It doesn't matter if it will not change the entire matrix once you make sure that all entries of the same row goes together as to which row you're going to place or move them. I am proposing to use the row 2 as our new row 1, because for row 2, when you look at our second row, we already have a leading 1 and we have the next as 0, so it would be easier for us to use that as our first row and apply row operations with that. At the same time, I propose to use the row 3 as our new row 2. This is because we have here positive values of our entries, 1, 1, 1, 1, instead of 1, negative 1, 1, negative 1, which I believe might complicate for some who are still confused with operations. And of course, the row 1 will become the new row 3. It's the row 4 that we are not changing its placement. In short, I have here this version of this augmented matrix. We have 1, 0, 0, 0, 1. The row 2 becomes row 1. 1, 1, 1, 1, 3. The row 3 becomes row 2. 1, negative 1, 1. Negative 1, negative 1. The row 1 becomes row 3. And the row 4 stays as it is. Now from here, we are going to make sure now that all of the entries here on the first column for the first entry of the second, third, and fourth row will be reduced into 0. And with that, let's apply these processes. We'll multiply negative 1 to our row 1, add it to row 2 for the new row 2. Same thing, multiply negative 1 to row 1, that's row 1, plus row 3, and make it as our new row 3. Then, multiply again negative 1 to our row 1 plus row 4 for it to become the new row 4. So with that, the next here is this. The first row is still still this 1, 0, 0, 1. And then the next here is the application of the processes. So let's have the first set of operations. Negative 1 times 1 is negative 1 plus 1, 0. Then negative 1 times 0 is 0. So for this 3, nothing has been changed. 1, 1, 1 still. Negative 1 times 1 is negative 1 plus 3, we have positive 2. For the third row, negative 1 times 1 is negative 1 plus 1, 0. And the same as earlier, still have negative 1, 1, and negative 1 here, since all the entries here are of 0. Then, negative 1 times 1 is negative 1 plus negative 1 is negative 2. Next, negative 1 times 1 is negative 1 plus 1, 0. So we have reached our goal here. And then, same as earlier, 4, 16, and 64 still. Then negative 1 times 1, negative 1 plus negative 1, you will have negative 2 here as well. Next, since this is already 1, we don't need to use other operations with that, but we are going to make these next entries equal to 0. With that, let's just simply add row 2 and row 3 for our new row 3, because that will become 1 plus negative 1, so 0. And multiply negative 4 to row 2 plus row 3 for our new, sorry, not row 3, rather, plus row 4 for us to have the new row 4. I would like to place the entries here, but since it will still add more spaces, let us use the spaces below. Okay, so we'll have this next version here. So it's still 1, 0, 0, 0, 1. So the second row is still 0, 1, 1, 1, 2. But the third row, simply add 0 plus 0, 0. 1 plus negative 1, 0. 1 plus 1, 2. 1 plus negative 1 is 0. 2 plus negative 2, 0. Then 4 times 0 is 0, and then 0 here, like that. Negative 4 times 1 is negative 4 plus 4, 0. Negative 4 times 1 is negative 4 plus 16, 12. Negative 4 times 1 is negative 4 plus 64 is 60. Negative 4 times 2 is negative 8 plus negative 2 is negative 10. Alright. Then we multiply 1/2 to our row 3 for a new row 3 to make this a leading one. So you have this next process. Still 1, 0, 0, 0, 1. Still 0, 1, 1, 1, 2. Here 0, 0. That becomes 1 now. 0, 0. And the fourth row is still in this form. Alright. And from here, let's make this 0 now. We will multiply negative 12 to row number 3 plus row number 4 for a new row number 4. So we have 1, 0, 0, 0, 1, 0, 1, 1, 1, 2, 0, 0, 1, 0, 0. Here comes the changes. Negative 12 times 1 is negative 12 plus 12, 0. Negative 12 times 0, so it will still be 60. Times 0, it still be negative 10. Then we make this one. Okay, we divide or we multiply row number 4 by 1 over 60 for a new row number 4. Okay, alright. So it's 1, 0, 0, 0, 1, 0, 1, 1, 1, 2, 0, 0, 1, 0, 0, 0, 0, 0. We have here 60 times 1 over 60 is 1. Then negative 10 will become negative 1/6. So now we are done with the first phase, the forward phase. This is actually just a Gaussian elimination portion. But since our task is for the Gauss-Jordan elimination or the achievement of the reduced row echelon form, we are going to apply the backward phase, and we are going to make this next item 0 by using the fourth row. For that, we are going to multiply negative 1 to our row 4 plus row 2 to make in new row 2, making this 0. So this would become here 1, 0, 0, 0, 1. So the fourth row is still this. The third row is still this. Here comes the changes. Of course, this is still 0. That's still 1. This is still 1 because the multiplier is 0. So negative 1 times 1 is negative 1 plus 1, 0. Negative 1 times negative 1/6 is positive 1/6. Plus 2 is actually 12 over 6. So plus 1 because it's positive 1/6. I have 13/6. Okay. Last step. Make this equal to 0. So we multiply negative 1 to row number 3 plus row number 2 for a new row number 2. So this would be our final form here. So the fourth row is still 0, 0, 0, 1, negative 1, 6. It's still 0, 0, 1, 0, 0. The first row is still 1, 0, 0, 0, 1. And the second row will still be 0, 1. Negative 1 times 1 is negative 1 plus 1, 0. Negative 1 times 0, so it will not change. Negative 1 times 0 plus 13/6 is still 13/6. Look at our final result. This is already in a reduced row echelon form. Okay, look at the values of leading 1, and for all the columns, for the first column to column 4, aside from 1, all other entries are 0. So if this is related to a linear system, and we're talking about solutions to the given variables, and if we say they're all x, that in terms of x of 1, x of 2, x of 3, and x of 4, we could say that the result is x of 1 is 1. X of 2 is 13/6. X of 3 is 0, or in short, there's no value for x of 3. And then x of 4 is negative 1/6. This is an additional idea. If this original matrix is translated from a linear system, and this would mean that this is our solution. Either way, from here or in this portion, we already reached the task for this video, which is the Gauss-Jordan elimination of the given matrix. Thank you for watching.